Hello everyone, my name is Jessica Wojciechowski and I'm a PhD student from the University of South Australia, and today I'll be presenting about the Shiny package for R and providing a basic introduction to the Shiny framework from a more pharmacometrics point of view. This is a working group session today, so I'm actually currently visiting the University of Maryland, Baltimore with the Center of Translational Medicine, and I'm joined by some of the partners in the group here in the room. Throughout the session, you may hear them ask some questions, and I'll repeat their questions and we will stop and discuss them. And for everyone else, feel free to ask questions as we go along as well. You can post questions on the Discuss ISOP event is listed, which is just down here. And then you can, I'll try and address these questions towards the end of the presentation. I'll just start with some housekeeping things as well. So on GitHub, the issue for the today's session is here as follows. There is some background resources if you would like to have a look, such as the Shiny R Studio website. A link to the Shiny tutorial paper that was published in CPT PSP last year. Throughout the session, I'll demonstrate an example application, and we'll make some amendments to it. So if you want to follow along, you can download this zip file, and it will contain 2 scripts to develop to use the Shiny app, and you can load them into RStudio, but I'll describe and show you how to actually do that later in the presentation. The next housekeeping thing is that on the Pharmacometrics study group page, which opens up here first, if you scroll down, there's some events that are listed. So today is the introduction to the Shiny framework for pharmacometrics. Week there is an introduction to PK/NCA, so you might want to listen to that one as well. More housekeeping. There is a ISOP Shiny server that people are allowed to we're trying to get the pharmacometrics community more involved in developing Shiny applications and sharing them with everyone else. So ISOP has our own Shiny server from RStudio where people can upload their applications and share them with the rest of the community. For instructions on how to do that, there's information on the ISOP website, and you just follow the URL as shown here. So I think that's all. So we'll get started. As I go through this session, we'll switch between, I have some slides, and then I have some running applications to demonstrate, and then we'll also flick to RStudio to look at the code. So let's get started. So as this is an introductory session for those who are not familiar with Shiny, today's topics will consist of demonstrating some basic examples of applications developed using R and the Shiny package. Link back to that ISOP issue where you can find the example application for today. We'll also talk about exactly what is Shiny and why a pharmacometrician would want to use the Shiny package. And also how the Shiny package will work in relation with your R scripts. More advanced concepts can be addressed in later ISOP study group sessions, either by myself or anyone else who wishes to share their Shiny experiences and or knowledge. So I thought I'd start with a really simple example application, which I'll go to the running application here. You can see the application is running in Google Chrome. Because these applications can either run from RStudio or an external web browser. So this is an application that explores a few different distributions and allows the user to visualize distribution densities and shapes when parameter values are changed. I as a learning tool for myself because there were a few distributions that I wasn't familiar with, and this allowed me to explore their parameter values. So the application opens up with a normal distribution. Actually, I should refresh this. With a normal distribution with mean of 0 and a standard deviation of 1. The sliders here on the left-hand side allow the user to manipulate the distribution. So as these slider values change, the plot updates automatically with just the change of the slider. So an example is here, if I move the standard deviation back to 1, but only change the mean, you can see how then the distribution moves along the x-axis as I move the slider value. I also have a drop-down box here where you can explore different distributions. So there's also a log normal or an inverse gamma. And you can see then when I pick the inverse gamma that the sliders also changed to accommodate the parameters of this distribution because it's not parameterized in mean and standard deviation, but alpha and beta. And when you change this, when I changed alpha, the scale mainly changed, but when I change beta, the distribution, you see more bigger changes in the distribution. You can see here with using a Shiny application, I'm able to explore different values for parameters and instantaneously see the updated plot. If I was doing this with a standard R script, I would have to either rerun it multiple times with different values for each parameter and then save each static plot later, or plot all the different scenarios on, for the different parameter values on the same plot, which could get really messy. So it is the automatic updating of output when input changes, which is the key feature of the Shiny application, compared to your standard R scripts. So if I go back to the slides. So what is Shiny? So Shiny is an open source package for RStudio for R that allows R programmers to interactively show the output for their R programs. You're able to have control encoding the elements of the application's user interface and their position without knowing HTML, CSS, or JavaScript. Just like when you write an R script, with Shiny, you still have control in generating your output. So this can be controlling the appearance of your plots using plot2 package, as well as structure of tables and text and any other numerical summary that you want. Whilst I won't go too much into detail about this today, Shiny applications can be shared and viewed in web browsers via the internet and accessed by URLs. This is particularly useful when you want to share your application with someone who is not familiar with R and probably does not have an existing installation of R on their computer. The example that I want to work through today is an application that simulates a one-compartment first-order oral absorption concentration time profile that updates when we change the dose slider. So if I go to the running application in the web browser here, so in the background of the application, I have fixed the parameter values of the model, such as clearance and the volume of distribution and the absorption rate constant. And the application, and it has a predefined time sequence for which it will calculate concentrations. But the only input from the user interface that's available to the user is this slider down here at the bottom for dose. On the application initiation, which if I refresh it, it starts at a 50 milligram dose and you can see the resulting concentration time profile. But when I move the slider to 100 milligrams, you can see the plot has automatically updated and you can see the doubling in the concentrations. So this is the application that was available in the zip file that we will go through its code and make some amendments throughout this session. But firstly, what is actually required to make an application? So Shiny applications are built using two R scripts that communicate with each other. there's a user interface script named UI.R, which controls the layout and the application's appearance. There's also a server script named server.r that incorporates instructions for the user input, processing data, and output by utilizing the R language and any functions the programmer has written and any other installed packages that the programmer wants to be used. These two scripts need to be saved as so, and then saved in the same folder so that R knows that the two combined form one application. So I don't know how well this may be shown on the in the live stream, but this is an RStudio window with an application loaded into it. So it has a server R and a UI.R, but I might go to actual RStudio so that and increase the font a bit. Actually, I'll go to the other app. Oops. That one. So this is the running my RStudio window with an application loaded into it. So there's two ways. There are a few different ways that you can run a Shiny app, but the easiest way is to do it from RStudio, which is an integrated development environment for R, as shown here. Firstly, you need to install the Shiny package, which can easily be done so by the Packages tab. There we go. And just clicking install, and then you can type in Shiny. You also need to check what other packages that you want to use or that the programmer has used to install those packages as well. So this application also uses ggplot2, so you would need an installation of that to also be able to run the application. Then you would need to open up the UI and server.r scripts in RStudio. RStudio recognizes that these scripts form a Shiny application, and what will happen is that this Run App button here will appear. Next to the Run App button, there is a drop-down menu with a few options. So you can either run externally, which would run in an external web browser like Google Chrome, or you can run in an additional window that will pop up from RStudio, or you can run in the viewer pane of your RStudio environment. Finally, any errors associated with the code will come up in the console like usual, like when you run a normal R script. Errors will come up for both Shiny errors, but also your other R programming errors. So that's just how to run an application and how to load it. So what is the UI.R and what are some of the functions that are in this that would be used in this script? So creating a user interface for your application is easy when you understand the general structure for the code. For the next couple of slides, I'll describe some of the functions that are used for creating a user interface, and then we'll work through the code for the example application. The Shiny package comes with a suite of customizable and pre-built widget functions that are highly intuitive that you can use. So there are layout functions such as fluid page and fixed page, and these will create a layout for the entire page. All other functions then need to be within the braces or brackets of these functions. Then you would have a function that positions whatever object you want in the user interface, and some of these functions include fluid row, fixed row. Each of these functions have their own specific arguments that will then structure and rearrange and arrange your input and output. Then there are elements, and these are the functions for coding widgets or outputs such as plots that change with widget input, any headings, line breaks, images that you want to put in your user interface. And then as you can see, it follows a hierarchical structure where element functions such as input widgets and output are placed within a positioning function, which is then within a layout function. You can have multiple elements, so multiple widgets or sliders can be in the same positioning function, and they're just simply followed by a comma. So the widgets are actually what makes the application quite interactive, and they need to be written into the user interface code. They allow the user to explore different values or categories for your variables. And then they store that value chosen by the user, which is then involved in a cascade of functions in the server.r, which is the application's instructions object, which is then dependent on the widget's value. So changing a widget will then will change the resulting output object. Examples of these widgets, which we've already seen in the examples shown earlier, are sliders and selection, like the drop-down selection boxes. But there are also check boxes and radio buttons and download buttons as well. The output that changes with widget input also needs to be placed somewhere in the user interface. There are a series of functions that call R objects from server.r into the user interface. These functions are specific for that type of object. So if you have a ggplot2 object, a plot, that is written in server.r, which is the application's instructions, that needs to be called into the user interface using the plot output function. So that's probably enough talking. We'll have a look at the code for this application. Let's see. This one? No. There we go. And I'll make this a little bit easier to read. So I'll click on the UI.r because we'll talk about this one first. So we'll start from the top. So I have a few comments, but then at the top is fixed page, and this is our layout function. And it creates a page that aligns elements such as input control widgets or output plots and text in rows and columns in a fixed width, so that when you change your web browser, the size of your web browser, everything stays in the same position. Then everything, in this example, everything within fixed page is an element. So the h3 function creates a heading, and this has been adopted from HTML. Then we make a horizontal line that will appear below the heading. Then below the horizontal line is the plot output function, which calls in our output plot called concplot, which is an object that was defined in server.r. And I've also fixed the width of it to 600 pixels so that it looks pretty. Then underneath the plot, there is a slider for dose. So your slider or widgets need to have a name, and this name is then referred to in the server.r script. And then there's also a label so that you can you can have it a bit more of a descriptive label in your user interface, and that's what the user will see. So the object is called dose, but then the label will show dose in milligrams on the application's user interface. This widget for a slider is because it's a continuous scale. I set a minimum and a maximum so I constrain doses that the user can pick. I want it in steps of 5 milligrams from 10 to 100, and I want my starting value to be 50 when the application is run for the first time. And then you're just going to make sure that you close all your parentheses around all your functions, because everything is embedded within each other. So now the server. So the server.r script can sometimes be a little bit more complicated, depending on how complicated your program is or how much output you want your application to show. For those that are experienced with R, however, Writing server.r just consists of using the same packages with the same functions and arguments to process information as you previously would have done in your standard R script. The only difference here is where some of the code actually needs to be placed in this script, as Shiny will rerun parts of the server.r code every time a widget changes. So every time the slider will change, parts of the server.r will rerun. Therefore, you don't want computationally intense code that does not change when a widget changes to be run every time, because it will slow down your application and the update time of whatever output you have. So you need to think about which parts of your code are what we call reactive and what is non-reactive. So a non-reactive object, these have values that are not dependent on input from widgets. So these would be package libraries that you want to load, because they don't need to be loaded every time you change a slider. Constant expressions, such as one that's creating a time sequence, or if you choose to preload a data set into the application. Therefore, objects that are reactive are those that are dependent on the widget input. These reactive objects need to be coded within the function called Shiny Server. And it is this code in Shiny Server that is rerun when a widget changes. Code outside of Shiny Server, but still within server.r, is run only once when the application is run for the first time. So the most basic reactive object is the value itself from that comes from the widget. So that would be in UI.r, the value for dose is reactive in server.r. And that's just a simple reactive object. Therefore, any object, such as a plot, table, or text that is in some way dependent on widget input also needs to be placed within the Shiny Server function. The code creating that object also needs to be within a render function. And this object is given the name that is then used in the user interface script, or UI.r, for positioning it into the application. So just like our plot output called a plot object from server.r to the user interface script in the UI.r, render plot creates the reactive plot object in server.r that will then be sent to the user interface. So when we look at the code for this application, so now I'll click to the server.r script. From the top, again, I have all the non-reactive objects that aren't dependent on widget input are at the top. So these are my package libraries. I have then a custom ggplot theme that I like to use, and then my time sequence as well, which is just that it's just a sequence that's 0 to 24 hours at variable increments. Then underneath is all our reactive objects, and everything is within the Shiny Server function and within its curly braces. So conc plot is defined as an output object, and all of its information is within render plot. So each of the, what I will then do is like each of the widget input is called in using like the input object. Then I have the model structure. So I've just preset weight to 70, creating clearance to 90. These are the model's parameters that are dependent on weight and creating clearance, but they won't change because weight and creating clearance aren't reactive. I just have them here as an example to begin with.
So they can be reactive too?
Yes, they can. We'll do that later on. And then we'll calculate concentrations. So that's just the one compartment first order oral absorption equation. And here is the resulting ggplot2 object that will be dependent on, that will plot time and concentration. Yes, I just want to check everyone in the room here is clear with all that. So what we might do now is, what if we want to add different sliders to this application? Yes, Elephant?
If you wanted to have a table associated with the plot, you would have another definition of blender table?
Yes, that's correct. So the question was, if you wanted a table output that matches with the plot, would you then use a function called rendered table? And yes, that's correct. You would have render plot will render a plot object, and then you would also then have to have a rendered table function that will then create a table and send a table to the user interface. You wouldn't be able to do it in this example exactly like that. We would have to take a few extra steps, but that might be just a little bit beyond the scope of this beginner tutorial. What we can do is see what happens if we want to instead add, instead of having a slider for dose. So at the moment you can pick any dose in 5 milligram increments from 10 to 100. But what if we only want people to only choose from 50 and 100 milligrams and nothing in between? So how do we go about doing that? What we could do, the first thing you could do is constrain the slider so that it only has 50 and 100 increments on it, but that's not that fun. So we can actually put a drop-down box where you can just only pick the 50 and 100 milligrams. We will do this by going to the user.r, oops, this one, the UI.r script. And instead of this being slider input, we will call it, it will be select input. And this is the function for the drop-down box. Shiny is really useful, helpful as well, that there's help for these functions as well. So if we want to see what arguments select input takes, you just put in the question mark and then the function, and then you can see what it has. So it has input ID, which is the name of the reactive object that would go into server.r. You still have the label, but instead this time it has choices. And these is where you'll put in the choices that you want your user to select from, and which isn't an argument that's in the slider input function. So instead of having min, max, and step, we'll remove these and change them to choices. And we will give a list of choices for the person. We'll give them something like a text or character string name, but we'll assign them to a value. So the 50 milligram one will be 1, and then the 100 milligram will be 2. So those will be our choices. We'll also then, we can pick which one of these two choices we want to be the value when the application is started up for the first time. So what we'll do is we'll change this to selected equal 1. And so when the application starts up, it will still start with the 50 milligram dose. So that's what you would change for the user, the UI.r. But we'd also need to, yes, Elephant?
How would it change the 50 milligram, which is a string, into a numeric?
Yep, so that's, we need to go to the server.r and we need to make some changes there. So each of these are assigned a value. So when we go to server.r, we'll just make some changes to our input dose. So I'll use an if statement. So if input dose equals 1, and dose will equal 50. And then if input dose equals 2, dose will equal 100. These objects, these doses, are reactive. They're dependent on whatever the input dose option was. So if we run the application now, we can see that the plot is still the same, but now instead of a slider for dose, we have a drop-down box and a selection box for dose, and we can pick 50, or if I pick 100, then I see the doubling of the concentrations again. We can also see what happens if we want to then have a slider for weight as well, because weight is a covariate, or is one of the parameters in this model that I've made up, but it is fixed to 70. So what happens if we want to change it to another value? So if we go back to the UI.R, we'll keep our dose select input, but then we can underneath add a slider. There we go. Slider for weight. So we'll go slider input. The object will, in the server, will be known as weight. The label we'll make as weight in kilograms. We'll make our minimum weight just equal 40 kilograms, maximum weight equal 100, and then we'll make the step can be every 1 kilogram. And then the value when the application starts up, we'll just make it 70. However, weight in server.r at the moment is not linked to the input value for weight. So all we need to do here is, instead of having it as 70, we'll make it input $weight. And now this weight will change depending on the slider that was defined in UI.R. So when we run it, we have our selection box for dose, but now underneath we also have a slider for weight. So if I change the weight, the concentrations now change as well. So the concentrations will get lower for a heavier person and then higher for a lighter person. And that's simply just how you add a couple basic sliders and change this application. So back to the slides. So why would a pharmacometrician want to use Shiny? R is a programming and statistical language that is common to many pharmacometricians. It's also flexible so that we can code our models in R as well. The part that Shiny adds is that we can rapidly, if you set up a model, a simulation model into an application, probably a little bit more extensive than the example I showed today, but you can rapidly test dosing scenarios by either predefining some of the doses or having a slider for dose, and then you can see what happens when you change the dose, or you can have a slider for different regimens if you want IV bolus or an infusion or dose frequency. You can explore the impact of your model's covariate effects by changing the sliders. So we could see the impact of weight before when we had weight as a slider. You can identify initial parameter estimates prior to your population modeling. So you can fine tune them by giving yourself some sliders and then having that plot against your observed data and see if your initial estimates are at least in the correct ballpark before you start modeling. You can demonstrate the properties of the model itself to a collaborating clinician, because the equations from models aren't that intuitive, but a nice plot where they can see what happens when you change dose with a certain drug or change a regimen. They can see the plot update. These tools, these Shiny applications probably have a nice role for teaching pharmacokinetic and pharmacodynamic principles to students, as they can also play around with the input themselves and see what happens when they change dose or frequency. They also can then be helpful if you want to share your work with others who are not so familiar with or do not have an installation of R on their computer. And this comes from uploading them online with our Studio Shiny Server or other Shiny Server resources, because they can just be accessed from the URL rather than sending someone the server and the UI scripts. And then you can also then develop. They're relatively easy to develop, and they can just be a nice prototype prior to formal web app development. So there are a number of useful Shiny resources for those who are keen to develop their own applications. My number one would be to go to the Shiny by RStudio website, because they have a number of great tutorials and videos on how to develop these applications right from the basics. But then there's also some other discussion forums and question forums like Stack Overflow and GitHub, where people also post some issues. Last year, there was also a paper published in Clinical Pharmacology, Pharmacometrics and Systems Pharmacology on Shiny, which has some pharmacometrics examples in there, particularly more for simulation. And with example code for each, there's 3 examples and example code for each of them as well, which you can use as a nice template if you want to further develop applications. There was also a Shiny tutorial at ACOP last year, and all the resources are on the Discuss ISOP website as well, and there's the link as below. So there are also a lot of concepts that I haven't covered in this session, just because it was a beginner's session. So there's this concept of reactive and isolate expressions, and essentially these will allow you to still create a reactive object that is dependent on widget input, but it's not necessarily straight as it might not be a plot that would go to the user interface. It might not be a table that will go to the user interface. It's kind of the middleman. The question before about having a plot and a table, what you could have is put all your processing information in a reactive expression, and then the result of that reactive expression then can feed into the render plot function that would then create the plot, and a render table function which would then render the table. Isolate expressions, they just don't execute the reactive expression essentially until another action has been performed. So it's kind of sitting there waiting and isolates it from all the changes that are being made. I also haven't quite covered storing application output. Not so much about sharing Shiny applications, but there is these web links below that if you wanted to explore more about, you can access these. There's also interactive documents and presentations that can be used with Shiny and R Markdown. There's a link below. Applications that implement population models and simulate variability from a population model. These are more to do with R programming rather than Shiny. And we've had already previous ISOP sessions where others have covered packages that simulate population models. So that's why I haven't covered it here. Also, I haven't covered more fancier, nicer user interface designs. So you can still integrate some of the other web programming languages into Shiny to make your application look a bit. There's also a package called Shiny Dashboard as well, which will create an application that looks like this screenshot below. And it has a bit more of a dashboard feel, it has a few more colors, and then there's a few options down the side where you can have different output and input. So whilst I haven't covered these concepts in this presentation, I'm simply just raising awareness of them for you to explore once you've understood the basics of the Shiny framework. And so this comes to the conclusion of my presentation. of an introduction to the Shiny framework for pharmacometrics. I hope the information I've provided here today is sufficient to motivate you to start creating your own Shiny apps. And I'll upload the slides for this presentation this afternoon. But I definitely encourage anyone else who's been using Shiny in a pharmacometrics sense to also set up a study group session and share with the rest of us, especially a few more of the advanced concepts that I already brought up or anything else that they may know. So I will just go and have a look at the ISOP page to see if there are any questions.
Last one.
The last one? In your experience, how well does Shiny work with apps that take a long time to run? Is there a way to indicate if an app is running, for example, during a long simulation or during fitting? So a lot of the slow part that comes from these things is R itself. But there are a lot of packages that I think the classic example I had in the Shiny tutorial was that I used dsol for the differential equations, which can be quite slow. And since then, we've already had some sessions on faster differential equation solver packages. So that more is coming from R rather than Shiny itself. Is there a way to indicate if an app is running, for example, during a long simulation? Yes, there is. I've actually probably a bit beyond, and I don't have it on the top of my head right now. Yes, there is a progress indicator that you can have that can appear on the web page, and you can have a little message that will come up and say, oh, I think one example I had was that currently simulating confidence intervals, so that you can let whoever's using it know that it is actually doing some calculations in the background, but it's just taking a little bit longer so that they don't get frustrated or don't try to rerun the application. When I first started using Shiny, when you had a long process running, sometimes the plot, if you had a plot updating, it would grey out as well, so that you could see that it was still updating and wait whilst you were waiting for the background calculations to finish. I'll just check if there's any other questions. No. So thank you for listening today. Thanks.